Hello there and welcome to a new lesson. In this one we are going to be creating the player, okay? The thing is that we want to add the player, the camera movement, so that we can actually start seeing something inside of the game window. So I will start off by creating the sprite for the player. So this is going to be called SPR player, and then the object that is going to be named OBJ player. Okay, let's now import the player sprite. So here we have it. Now inside of the sprite I'm going to center the anchors. Okay, so I will set them to be in the middle center. Why? In most cases when you want to have a sprite that you are moving inside of the screen, and then for example we are going to be creating a health bar for it, so we are going to be drawing things through code, it is going to be much easier to position these things. Why? Because the central point of the player, basically the 0, 0 of the player, is the exact center of it. So referring to the center of the object when wanting to center, for example, a health bar around its head, is going to be much simpler, because we can just refer to the 0, 0 of the player. We would have the center point, and from the center point, for example, if we want to draw the health bar, we can just say, okay, increase the Y by, I don't know, 10 pixels, and you have the health bar completely centered without having to do some calculations. This will make much more sense when we, for example, start drawing the health bars. Let's also load in here the sprite. And now I will actually position it in my window. So inside of the instances layer, I will drag and drop the OBJ player. Then I will double click inside of the player, and I will increase its scale to something like 3.5 in both axes, since well it is quite small right now. And well, there we have it. It does look much more accurate, because if it were so small it would be impossible to see it in the screen. So now I will actually code the movement. First of all, in the create event, I will create a variable that is going to be current velocity, okay? And for example, my velocity will be 4. Then in the step event, okay, that is called at every frame, here is where we are going to be handling the actual player movement. So first of all, I need to get the inputs, okay? So I want to know when I am pressing the arrows, in order to then, with those inputs, be able to see where the player should move. So I will create all these with variables. So the first one is going to be right, and this is going to be equal to keyboard check. Okay, and here vk right. Okay, so this variable will always be checking for this exact input, okay, in this case for the right key. Now I will actually copy and paste this line 3 more times, okay, so that we have it for all the other arrows. So then we would have, for example, left, and we would check for the left arrow. Then we have up, and we check for the up arrow, and finally we have the down. So there we go. And with this, well, we are getting all the inputs that we need. Now, depending on if we are pressing some arrow or the other, if we are not pressing any arrow, well, these variables will contain different values. So to demonstrate these values, I will basically print them or show them so that we can see what values they would contain. So I will show the right variable, and then I will also show the left, okay, so that we see how they both work. So here we are. Of course, our camera doesn't look good since we aren't moving it with the player, so it's not like aligned with it. But we can see here that if we are not pressing any of the keys, they return 0, okay? Then I'm going to press the right key and I will keep it pressed. And you can see when you are pressing a key, that value will return 1. I will not press it anymore and it will come back to 0. Then if I'm pressing now, for example, the left, I will also get the 1. I stop and I get 0. Now I will press both at the same time. And as you see, I'm getting 1. And when I stop pressing them, I get 0 back again in both. And now you may be thinking, why is this important? Because by knowing this, we are going to be able to determine the X and the Y direction for our player. Because if the direction is 0, it means that there is no key that is being pressed down. Therefore, the player shouldn't be moving. Now, if for example, the X direction is -1, the player should be moving left. And if the direction is 1, the player should be moving right. So how do we actually know this? Or how can we actually be able to know this? I'm going to create other variable that I will name var X direction. And this is going to be equal to the difference between right and left. Okay, so remember that when we are pressing any of these inputs, I get a 1. So if I am pressing the right over here, I'm having here 1. And then if I am not pressing the left, I'm getting 0. So 1 minus 0 is 1. Therefore, the direction is going to be right, and that would be okay. Since if I am pressing only the right arrow, I should be moving right. Because I would be getting here in this X direction 1, and that is okay. Then on the other hand, if I am only pressing left, I would be getting here 0 on the right since I am not pressing it. And in the left, I will be getting 1. 0 minus 1 minus 1. Okay? And therefore, the direction X would be correct. Now, I'm going to be doing something quite similar, but with the Y direction. So this is going to be equal to, in this case, down minus up. Okay? So, if I am pressing the down arrow, I will get here a 1 and here a 0. Therefore, I will have a 1. And remember that in GameMaker, if you want to move down, you actually have to increase the Y. And if you want to move up, you have to decrease the Y. So therefore, if we are pressing the down arrow key, and here we get a 1, and we are not pressing the up arrow key, we get a 0. 1 minus 0 is equal to 1. Therefore, we would be indeed moving down. Since when we increase in the Y axis, we move down in GameMaker. And the other way around would be with the up. We would be getting here a 0 since we wouldn't be pressing the down arrow. And then we would be getting a 1 when we're pressing the up. So we would be getting -1. And in GameMaker, when you want to move up, you have to decrease the Y. So this is correct. We can actually check this out. In this case, I will just show the X direction because the Y direction is going to work in the exact same way, so there is no need. So here I'm getting 0 since I am not pressing anything, but now I will press the left, for example, and I'm getting there -1. I am not pressing 0, now I will press right and getting a 1. So the direction is going correctly. Now I will delete here this line, and well, with this we were able to detect the inputs and then to calculate the directions based on these inputs. But well, we aren't moving. We're calculating, let's say, mostly everything that we need to move, but we aren't moving yet. So in our following lesson, we will actually see how we can move the player. So I will see you there. Hi there and welcome to a new lesson. In this one, we will be able to actually move the player and also move the camera, okay? Because we are doing all the calculations that we need in order to move the player, but we aren't yet moving it. So in order to move it, we're going to be using the move and collide method, okay? It is quite simple to use, okay? The implementation isn't that complicated. But well, anyway, I wanted to refer you to this post because it does explain interesting things. It provides other example if you want to check out for you to understand even better how move and collide works. But well, as you can see, in most cases it is doing something quite similar to what we are doing. It's calculating the difference between the right and left, then the difference between down and up. So in this is going to be quite similar to what we are doing here. So we will actually get to moving our player. So I'm going to be calling move and collide. Well, here this function does take lots of parameters that we have to carefully understand. The first two are the most simple ones, okay? We just have to provide the x direction and the y direction, okay? But also what you have to know is that we are going to be multiplying this by our current velocity, because if not we would be moving at a velocity of something like -1 or 1, and that is super slow. So if we multiply, for example, -1 times this variable that was 4, we would be moving at -4 of speed, and that is 4 times bigger than -1, so it is much faster. And we'll do the same thing but with the y direction. So I'm going to multiply this by current velocity. And then the third argument is an object, okay? And in this case it's going to be the obj wall. So basically here you can provide any kinds of object that you want to check for collisions while moving, okay? And this will allow you to, let's say, glide over slightly the object that you are providing here. In the player, maybe this isn't super spotted, but in the enemy, once we create the AI, that the only thing that will do is follow the player. When we actually use move and collide there and provide here the wall, you will see that they are going to be able to glide over the wall a little bit, and that can avoid in some cases the object from being stuck. And now when we play, we do see our player moving, okay? Of course, right now we don't have the camera following us, but you can see, for example, I now can collide with the walls, okay, and I can't trespass them, okay? So there we have it. But also something that you may notice is the fact that if you move diagonally, okay, as you can see, it is much faster. For example, let's say that I'm moving right, and now I'm moving upright. As you can see, it is much faster. So basically what is happening here is that we have to limit the speed, that the maximum speed that the player can have. And here this is pretty well explained in the post, okay? So after providing here the object that they want to check collisions with, they also write here 3 other parameters, okay, that these parameters, they aren't changing them, okay? They basically follow the values that are in the manual, because they don't want to get into more complex things, they don't want to modify them. And then you can check here for the max x movement and the max y movement. And in this case you will basically use your speed or velocity variable that you are using in order to limit the movement, so that your actual movement can't have a speed that is bigger than the speed that you have set. If you click over here, it will take you to the manual, and when you scroll down a little bit, you will find what these other values that are being used as the default values. We have here, well, the distance, x and y, then you have the object, so these 3 we have already covered them. And then we have these 3, okay, and then the 2 that we are most interested in, that is the max x move and the max y move. And here, well, we do see that the default value, well, is in this first case 4, and in the other 2 cases is 0, okay, to use the default behavior. So basically, for example, these last 2, okay, will basically change the direction depending on the if there is some kind of collision, okay, it will move a little bit our player. But well, in this case, the only thing that we want to do when we collide, in this case with the wall, okay, is basically stop moving, okay. So that's why these 2 values, we are keeping them with the default values. And then here the iterations basically will determine how fast we want to check for collisions. depending on the exact steps that the player takes. So basically, to avoid falling into more complicated things, we will just use the default values for those three, and then we will use our velocity. So here we're going to provide 4 for the number of iteration and 0 for both offsets. And right here we're going to provide the velocity so that we can limit the movement. And now, okay, even though you may try to move diagonally, you will always be moving at a constant speed, okay? And of course you cannot move through walls. Now it is time to update the camera position, okay? So here on the top, okay, I will do this. So we have, as I explained in the viewport lesson, we have to change the camera position. And how we do so is by using camera set view position, okay? Here we first have to provide the camera that we want to modify. And in this case, we just have one camera and we are using the first camera. So this is going to be view camera 0. And then the X and Y positions. So here, for example, if we want to move it with our player, you may think about, okay, just right here my current X and my current Y. So that I can basically make my camera position equal to my current position. But when we try this out, what's going to happen is that, well, yes, indeed, our camera is updating its position. But the thing is that we are not centered in the view, okay? So we must center the camera view in our player. And this is when the viewport size that we set is going to be quite useful, okay? Because if here to our current X, we decrease the global.viewport width and we divide this by 2, will basically mean make my camera, okay, v equal to the X size, to the X position, and then subtract half of the viewport width. Because here, let's check again how this was looking like for you to understand why this calculation works. We were on the top left. So if we take half of the viewport, okay, and we position it on the left of the player, there we will have like the viewport in the exact place where we want it. If we take something like this, okay, and we move the other half, okay, to the left, we would have the player, or actually the camera, where we wanted. So we would do this, and for the Y it's going to be something quite similar. We're going to be subtracting because we want to be moving up our camera. Here we want to do minus global dot viewport height divided by 2. And now we do have our camera centered in our player, and we are going to be able to actually move with it. And with this we have successfully finished, at least with the basic setup of the player movements and camera settings. Hello there and welcome to a new lesson. In this one we are going to be creating the dagger, okay? So in order to actually create this attack, we will have to go through lots of lessons, and we will even come back to creating more with more lessons in between, because maybe we create the basic setup for the dagger basically being able to attack, and then we create more attacks, okay, and then we come back and actually, for example, we try to do the damage to the enemy, okay, because we do have lots of mechanics and features to implement in our project in terms of just one attack type. Once that this is said, let's create the sprites for the dagger. So I'm going to call it SPR dagger, and I will also create the corresponding object, okay? So obj dagger. Now here let's import the sprite of it. So it was this one, melee, okay, and then I will load this sprite in my dagger object. Okay, now I will open up my init script, and in order to create this attack type, and I would say that also other attack types, we're going to be relying on alarms, okay, to do the different things. Okay, and when we are using alarms, a pretty good practice is to have a global variable that will have the frame rate. Okay, so it's going to be global dot frame rate, and we are going to make this equal to game underscore get speed, and this is going to be the game speed FPS. So now having here the actual game speed, okay, the frame rate, when we are calling alarms, we're going to be calling them with real seconds, because when you are calling alarms, what you do is basically, for example, do this, okay, and then you write here the amount of steps that you want. For example, something like 60 steps is usually equal to 1 real second. So here, instead of doing that, what you do is write global.framerate, and you multiply this by the actual seconds that you want to pass in order to call that alarm. So it is a little bit easier, and it's also useful because if the game speed you change it or it is changed, well, you will also make sure that it is always called at the same time. First of all, I will go ahead and drag and drop here the dagger. So as you can see, it's going to be super small. So in the create event, I will make it bigger with image X scale, and I will modify its X scale to something like 3.5, and I will do the same thing but with the Y scale, so 3.5. And now as you can see, our dagger is much bigger. Now as you can see, for example, it is not following our player, and what I want to do is to basically follow the mouse direction so that it can like rotate around the player. So in order to do this in the step event, what I will do is the following. I will set my current image angle, so this is the angle that the image has, the rotation, and I will make this equal to point direction. And basically the point direction, in this case, what it's going to allow us to do is to know where certain position is, and basically we'll return that. So what we want to do here is to rotate towards our mouse position. So to do this, here we do here it must provide the two initial X and Y, and then the two target X and Y. So our initial X and Y is basically X and Y, okay? And then our target is mouse X and mouse Y. That is basically the mouse vertically and horizontally, mouse Y. So basically this will return the direction, okay, of this vector that we have formed. So it is as, for example, we have here the player and the mouse is over here. So in this case, the vector will return the direction of this formed by x1, y1, and then 2x2 and y2. So x1 and y1 is our player position, and x2 and y2 is my mouse position. So it will return the direction between this vector that we are forming, basically that this line that we are forming, okay? And when we play, well, we do see some kinds of similar effect, but as you can see, it is not following our mouse as it should, okay? So basically a pretty easy way of fixing this is here, besides doing this, also subtracting 90. And when we do this, we do have a much better approach, because now my sword is pointing to my mouse. Also, other thing, I will just manually, then we'll do it by code, I will put the sword in the exact position where my player currently is, having the grid disabled, and then I will just enable it over there. Okay, and well, as you can see, it kind of works, but it is still a little bit weird, because well, the rotation isn't as smooth as it should be. So in this case, the way in which this is quite straightforward to fix is basically changing the anchor position. Okay, so I told you the anchor is the position in which, from which these, in this case, positions, angles, from the position from where everything is being calculated about the object. So we are rotating here the dagger following this anchor that is on the top left by default. But if we move it to something like, for example, here we can change it to something like 823. Okay, that if we zoom out a little bit, you will find that it is on the bottom. So it is like in a position in which you would take the sword in, and it is also a little bit from the bottom. This will create some separation between the player and the sword. So now when we do this, we do see the effect that we are looking, okay? And here, for example, if you don't understand why we are leaving this space, we can move it back here, for example, to the bottom center, and it will kind of work. But as you can see, we have no space when we are rotating, okay? It is always like in the same position visually, but when we modify the anchor Y position, basically it is going to be rotating from this point, and every time that this is rotating, it will rotate something like this. Okay, let me make this a little bit bigger so that we see it. So it will rotate, creating a circle doing this. Okay, so it will not rotate exactly around the sword, but will leave here some kind of offset, whereas if it would be exactly right here, it would rotate exactly around the sword, but we want to leave there some offset, some separation. That's why here I'm making this position a little bit bigger in terms of the Y. And then on the X, I am putting in here on the bottom of it, on the center, just where the handler is of the sword, okay, so that it is even more accurate. And when we do this, we do achieve a much better result. Then we will actually position this sword even better by code to make it exactly equal to the player, because as you can see, it's not currently super accurate. Because, for example, when I am pointing to this direction, we see that we have much separation from the player sprite than when we are pointing down, okay? And this is because we haven't centered the sword correctly. Yes, because we changed the anchor's position. So if we adjust this, having the grid disabled, exactly like this, we should be getting a way better result. But actually, as then we are scaling in this object by code, then it is also breaking here this logic. So we'll actually get to position the sword a little bit better in the following lessons, okay?